Hey everybody, welcome to the stream tonight. Looks like we already got a few people showing up. Got the old standbys showing up. That's great. Um, so tonight we're gonna take a look at the new duplicate elements node that I spent about 2 months writing the code for, and got a lot of help from uh, Han Scouty and Jacques Luc, uh, two of the on staff Blender developers, did a lot of code review for me and also encouraged me. I kind of had gotten to a point on that code where I wasn't sure I was going to actually be able to make it work, and they were really encouraging to keep going on it, and we made it happen. So uh, let's jump into it. It's got a bunch of features for sure, or at least a bunch of modes that it can work in, and it's going to get a small upgrade when we move to the new. There's some new curve data backends that are going to be added in here probably in the next week or so, and so the node will get some updates. It probably won't change any of the front end functionality, but hopefully on the back end, it's going to make the curves more efficient, and it's going to open up opportunities for some other cool things that we're looking at doing with curves, as far as being able to use them for in geometry nodes to be able to do like hair in geometry nodes and some things like that. So cool stuff on the horizon. Excuse me. So okay, let's let's jump in here. So I am gonna be on uh, Blender 3.20 Alpha. This was built just a little bit earlier today, so this is uh, this is new. This is the new version. Pretty much, if you downloaded the build from today, this morning, it'll be very similar to this. I don't know what all went in today, um, but for the most part, if you download today's build, you have what I have here. Um, and so, hey to everyone in the chat. Make sure you're chatting. I will try to keep an eye on the chat and answer questions as we go, um, if they're on topic. And in the end, if we get through this in a decent amount of time, and everybody's feeling it, and I'm still awake, we can maybe do it like a Q&A at the end, and I can answer some other questions. Yeah, I will maybe towards the end tonight. We'll look at the new Faces Planar mode node that I just committed as well. It's really specific, its uses, um, but it was a good piece of information to be able to access. So I'll like I said, I'll show that a little later um, on this evening. So for now, let's go ahead and jump into geometry nodes. All right. Oh, and do you guys want um me to put screen key the key, like the key presses? Do you want those on the screen or not, or is that annoying? Let me know in the chat. I can turn those on if they're helpful, but I know they can also be kind of annoying and in the way. So I would rather not be annoying and in the way. So let me know in the chat if you want those turned on, and I can do that. But for now, we'll go ahead and get started here. We'll just add it to our default cube, and get rid of that. Just put this over here. All right, so the basic idea behind the duplicate elements node is that really uh, any element, so whether it's instances, um, meshes uh, on the point, edge, or face domain, splines on the point and edge domain. I'm sorry, the point and spline domain. Uh, all right, cool guys. Yeah, I won't turn those on for now. Um, and then also on the point cloud point domain, because that's the only domain that point clouds have. But in any of those nodes, you can selectively duplicate your elements. So if I go ahead and add my duplicate elements node here, um, if I just plug in my cube again, you'll see that we get the the 8 corners of our cube. And one of the things to remember is when you're in either mesh or spline mode, all the duplicates are become their own element, if you will. So if you duplicate points, like in this case, you would get 8 individual points that aren't going to be connected by edges. If you duplicate edges, all of the edges are separated. And in face mode as well, all of the faces are disconnected. That was an important distinction that we put in there. That way, each thing became its own little entity that you can deal with. In um, in curve mode for splines, splines are already kind of their own thing, so that really doesn't change. But then if you're in points mode for splines, the control points actually each become their own spline of 1 point. That might be a little confusing off the bat, but just keep that in mind as you go forward. Obviously, point cloud points are already disconnected, so there's nothing different there, and instances don't have connections. So anyhow, back to where we were. I'll bring up the spreadsheet here just so we can keep an eye on what our actual data looks like. And so here I've got eight vertices with no edges, faces, or corners. And if I bump up the amount here to 2, they double. I mean, that's pretty obvious what's going on. Now, of course, we don't see any real differences because they're duplicated at the exact same position as the original. So one of the things that was necessary was the addition of this duplicate index. This is the index of each copy of the original. And the duplicate elements node only outputs the duplicates. It does not output the original geometry. So if you have 0 duplicates for a certain point or a certain whatever, if I dial this down to 0, I get nothing out. I don't get the original geometry plus 0 duplicates. I just get nothing. So if I wanted the original as well, I would have to do something like this to get the original and the duplicates. If I go ahead and put a viewer on this with a Control Shift click on the duplicate elements node, sorry, give me just a second. All right. I apologize for any drinking noises. This is not an ASMR video. That's all accidental. So if I go ahead and tie this viewer node in with my geometry and duplicate index, let's see here. So right now, I've got one duplicate on. So I'm only getting what could be considered the original 8 points of this cube. And so all of my duplicate indexes are 0. So this is the 0th copy. So, computer science, 0 is 1. We start with 0. So this is the 0th copy of each point. If I bump this up to 2, now you can see how the points are actually laid out in the field. So we've got our field of data here. So this first point that was at 1, 1, 1, its duplicate comes directly after it. And it gets a duplicate index of 1 here. Actually, if I get rid of this viewer node real quick and do click, click like that, Control Shift click on that twice, now this pulls up a viewer with an integer input, and that makes this look a little nicer over here. So you can see the duplicates are actually interwoven with with each one. So as we increase this, each point, so this point that's at 1, 1, 1, I get 3 of those, and their duplicate indexes are 0, 1, and 2. So this, now you won't use this every single time that you do duplicate elements, but I would guess that you're going to use this duplicate index a lot when you use this node, because really it does give you access to each original. It gives you access to the individual copies. So, for instance, if I were to, I'm going to get rid of this viewer node. If I want to spread these out, I could go ahead and I can add a set position node to my geometry. And then I can use the position, I could use the offset, really whatever I wanted to do. If I just plug in the duplicate index into the offset, you'll see we get this. So they're just kind of stacked because we're adding 1, 1, 1 to the first one, or I'm sorry, we're adding 0, 0, 0 to the first one, 1, 1, 1 to the second, 2, 2, 2 to the third. So this maybe isn't the best use of this. But what we could do is something like this. If we come in and alter this duplicate index into something more usable. So say we want to go on the point normals. And then what we could do is we could scale this point normal, because remember, a normal is just a vector with a length of 1 pointing in some direction. So if I take the normal vector of my points and then I multiply that by the duplicate index, this will spread out each point successively. We can do that using a vector math node. So with my vector math, I could say I want to scale my normal vector, drop that on there. And what I want to scale it by? I want to scale it by the duplicate index. So now the point transform node and join geometry does the same thing, right? No, transform node moves geometry in some direction, whereas join geometry actually combines geometries. So if, say, you have two cubes, and then you use a join geometry, you end up with one mesh that contains two cubes, but they don't move at all. Whereas a transform node takes one geometry input and then can move it around, can transform it, can rotate it, can scale it. All right, so now that I've got these scaled out by the point normals, because really these point normals in a uh, like a cube, they go out like diagonally from the corners. So if I zoom out from this and then I bump up this amount, we can really see what's going on here. One of the things we worked really hard in coding this node was to make it as multi-threaded as possible. So so when you're doing a lot of copies, when you've got, I don't know, 100 copies, 1,000 copies, whatever, it's gonna use it's gonna try to do it as efficiently as possible. So the node itself should be pretty quick. So even if you like really ramp this up to, here we've got 4,000 duplicates of each point, so I end up with 32,000.3 points. It is pretty quick. Now, of course, oh, I meant by saying a cube connected directly to the join geometry and the same cube connected to a transform node and then connected to the transform node can use the transform node. Well, okay, on the yeah, well, okay. Let me answer a couple questions here. So on the multi-threaded question, they are multi-threaded if they have been coded that way. Um, a bunch of the field evaluation is done in a multi-threaded way. That was one of the main things for fields, was to allow for, when a field is not being what's a good way to put it? When I'm not doing something like changing the size of the field, or if the field isn't like the accumulate node was one that really multi-threading wasn't really great for it because of the way it has to like work its way through the values in the node. Um, but for things like if you just did like an add or something like that, that is multi-threaded. And for this one, yeah, we did work in very specific multi-threaded calls. We built the mappings of like when you copy from one place to another. We built those into a way that could be accessed in a multi-threaded way. So yeah, we're working to make them as multi-threaded as possible, whenever possible. Okay, so next, as far as the transform versus set position goes, transform changes an entire geometry. So like if I want to move all of the points of a geometry up one on the Z, I could use a transform node and it will move all of the points of that geometry up at the same time, or rotate them or scale them, whatever. Whereas set position works on a per point basis. So I could put in a bunch of nodes here and have all of the points on one side of the mesh go in one direction and the others go in another direction, and the others be affected by a sine wave and the others be affected in whatever. it doesn't matter because it's affecting each point individually. Um, so maybe that answers your question. I don't know. Okay. So, all right, let's get back to where we were. One thing that you can do here, if if you don't like this spacing, always you can just add in like a math node, set it to set it to multiply here, and then you can use that to scale these in and out and do whatever you like. Um, of course, once you've got some points, what you do with them is up to you. You could go ahead and do an instance on points, and then I don't know, we could instance some icospheres like that, and you know, make we're making lots of spheres here. Um, so then, of course, here also you could capture this duplicate index if you wanted, or you could use this to do something like that, where now I am not only positioning the instances or positioning the points um, by the normal, but then I'm also scaling them dependent on which copy they are. So there we can get some cool effects. Something like that. So that's the basics of the points, and you can of course uh, the when you do this with splines, you get about the same sort of thing going on. Of course, another interesting thing that this allows you to do, and there some of the things you can do with uh, what does what does the node actually do? Well, the node is creating duplicates of your geometry. Um, one of the things that makes this interesting is that because this is completely field based, we're not set. Like if you were to do this with an instanced mesh line, say, and you set the positions with normals, like uh, um, yeah, like you mentioned, set position, translate instances along normals by index to achieve the same effect. Yeah, but this is something that you might not be able to do with that particular setup. If you notice, the amounts slider here is not a static single valued field like it would be if this was an instance of a mesh line. This is a field. So if I were to take something like an input index, so I'm just going to go back into my original mesh here, and I'm just going to delete this and add in cube back in just for simplicity. Now, if I plug this in, whoop, there we go. Now you'll notice that each point has a different amount of duplicates. This is one of the big things that's different with this than just instancing a mesh line. Because with the mesh line, you would have to you'd have to do a bunch of trickery and a lot of extra nodes to make this happen. Or I don't, it would be ugly for sure. But if I go ahead and grab this and do a multiply, now I can get different amounts of duplicates per uh, uh, per point. Let's say I come back here and I add a mesh subdivision surface node here. Okay, we're getting a little nutty here. I'm gonna bring this scale down a little bit. There we go. That looks a little better. So we've got that. Maybe instead of using an index, I could go ahead and use a texture, and I'll use I don't know, wave texture. Why not? And I plug that in here, and do this. We can get some pretty cool effects. Or if we go ahead and let's do a, I don't know, maybe we'll just do a noise texture. So now we're getting, now we're able to dynamically change the amount of copies per point. I think that might be, other than just cleaning up and not needing quite so many nodes to get the same effect as before, now you have more dynamic control over that effect. So let's take a look. And this was we'll base this basically on the image that I had posted, kind of the Minecrafty looking thing that I had done in my Twitter post when I talked about this node. All right, let's now there's a bunch of ways we could do this. I will try to do the simplest one I can think of for this evening. So let's go ahead and clear all this out. Actually, no. Let's not. Let's save this. Okay. All right. So what we could do is, there's a couple things we could do. The simplest idea is that if we've got a grid, um, say, we'll do a mesh primitive grid, and then we will do an instance on points. Um, okay, answer a couple questions. Shurendra, uh, your question: can we generate our own custom range of values rather than using field nodes, as this limits our range to calculate that can be done on fields? Okay, yeah. Um, I've got a couple of patches that I put together to kind of prototype that. Um, I I don't think the way that I had originally come up with to do that is going to be the way that we actually implement it in geometry nodes, but um, I think that that's going to be an option. Uh, Hopefully not in the not too distant future. I don't know about for 3.2. Maybe the version after that. But one of the things that uh, we are looking at doing is creating a concept called a list, and the list is going to be like um, a lot like a field, except it's more about a static set of data that can be operated on um, a little bit. While the fields concept has quite a bit of efficiency built in, it's only efficient when you are dealing with it in a certain way. And that is kind of with kind of these contiguous blocks of memory. To be honest, I grasp the concept lightly, exactly how it works behind, like way behind the scenes. That's a bit above my pay grade, which is zero. And But the list concept would let you create. It's almost like creating a field of a an arbitrary length that's not necessarily tied to a set of points or edges or faces. It's just a list of values that kind of exist on their own. And then when you need to apply those to a field, you could do that. And then that way, that arbitrary sized list doesn't need to have all of the trappings of the field concept, um, and can be a bit more, I don't know a good word for it, nebulous or whatever. It can be its own thing. And then you can work with it however you want. And then, okay, now I want to take this list and apply it as a set of values for this field. Um, I think will that's going to open up. There's a whole host of nodes that we've talked about. Some more like some more statistics nodes that work in like groupings. Um, that could benefit from that. Uh, a like a value import node like you're talking about, like that would be huge. I know there's a big group of, it's kind of science Twitter, that I've been having some fun chats with lately, that would really like that capability. um, you know Go grab a list of data from some file about a molecule and all of the atomic positions of all the particles in it, and then be able to drop those into geometry nodes and then just do it. um, Being able to parse like a text file and have that come in as a list of strings that you could then apply to the string to curves node and actually get multiple um, multiple entries from that. So I think there's a whole bunch of stuff that you can that I'm hoping we can do once we get that list concept programmed in. So it's still kind of in the idea phase. Um, we could hack it into fields, but we would actually, in the long run, be limiting what we could do with it by tying it directly to fields. I hope that answers your question. Will the hair system use geometry nodes? I hope so. I think that's the idea. It's actually going to be like um, particle nodes that generate curves. I think I'm not really on that particular group, so I don't know for sure. But I hope so. I think the idea is that more and more parts of Blender will be able to be used with node trees and interactions. But I know simulation nodes are probably one of the big next steps for this next year. Um, all right. What 3D software did I use first? I started in Blender. Turn turn of the century. Probably around 99 2000, when it was still before it went open source. I was using Blender, and um, I got into it, and I tried a few others. I tried Maya, like the learning edition, but I never really wanted to shell out any money for it. um, Tried Mudbox. I tried uh, Moto for a little bit. But yeah, I've just been a diehard fan. I was on the dev team back around '05 ish, for a little while, kind of when Elephant's Dream first came out. Uh, but yeah, always been a fan of Blender, and I've always enjoyed being part of the open source community around it. Um, cool. All right, so let's get back into this example. Now that I've answered a few questions. Uh, all right, so what we're gonna do initially here is we're just gonna instance a bunch of cubes on a grid. Nothing too fancy. So we'll go ahead and we'll bring in a mesh cube, drop that into the instance. Um, we want we'll just bump this up to there we go. So we got a 3x3 grid with 4x4 vertices. Um, uh, the approximate time on simulations with nodes, it's on the roadmap for this year, I think. Um, if you check out the code.blender.org, one of the posts I think has a rundown of um, kind of the next big milestones for nodes. Um, all right, so here we've got this gridded out now. Um, if we wanted to turn this into a 3D grid, of course, instead of instancing cubes on these points, we could have instead instanced um, mesh lines or curve lines, and then resampled those or subdivided those, whatever, and then instanced on those points. Like that would be one way we could do this. But in this case, let's go ahead and let's duplicate these individual blocks and move them in the Z direction. Um, so if I go ahead and I bring in a duplicate elements node, and now since I'm working with instances, I will bring this into instance mode. Do notice that if you do have instances, if you bring this into point or edge or face, edge doesn't show. The edges are there, they just don't show unless you do something with them. I don't know if that's a bug or a feature, but you can still work with them. But anyway, it will go into each instance and pull and try to pull out the mesh or the curve that are in those instances. So be aware of that. But I want to duplicate instances. And then I'll duplicate 4, so we get like a 4x4x4 grid. Now, again, these are all overlapping. We currently have 64 instances. So we need to move our duplicates. I'm sorry, I don't have 8 gig RAM for your PC. Sorry. Um, if I, I'm not a big time YouTuber. I don't. Maybe when I have a million subscribers, I can get you 8 gig of RAM for your PC. Um, uh, so anyhow, we'll go ahead and we will, since we're working with instances, we're going to use the translate instances node. We'll drop this here, and then we will use the duplicate index as our translation. Now, if I do this, we get this pattern because we've taken our because we've taken our duplicate index and we've applied it to all three components of our vector, our translation vector. So I'm going to get rid of this, bring this over. I'll drag this out and do a combine XYZ. And I just want the duplicate index to drive the Z. All right, so again, this is not something that this exact thing is not something you couldn't have done with existing nodes. But again, something that is not quite as easy would have been to set the amount for each one. So again, if I go ahead and I take something like we'll do a Musgrave texture and set that to the amount. But since that's I think that's a 0 to 1 or -1 to 0, I can never remember. And we will do a little math on it. Multiply. Okay. So now that we've got that, now we could increase our vertices, increase our size a little bit till we got something we wanted like this. Maybe something interesting. Of course, we could try a different texture if we wanted. You know, it really is up to you what you want to do. Now, one of the things that we've got here is I've got to adjust my size and my vertices based on, like, if I want, you know 20 by 20, I've got to adjust my size to fit that. But maybe I'll go off script a little bit here, but we'll see what we can do. Maybe I could do something different. So for a moment, I'm going to go ahead and I'll bring up my cube here and grab my duplicate int elements. All right. Oh, nothing's happening because this is not an instance. So I'm just going to go uh, geometry to instance. Okay. So I've got an instance of a cube. So now I could do something like translate instances, combine X, Y, Z, duplicate this on the X. So now this amount will drive my X. Well, if you can get my brain to work better than I can, you know what? I'll ship it to you in a jar because it doesn't always do much for me. Anyhow, um, so now we are using this amount to drive our our instances in the x direction. I could then take those, duplicate them, translate those duplicates, and then duplicate those in the y direction. Um, and what I'm going to do here is also, I'm just going to just add a little math node in here and multiply this by like 1.1, just so there's a little gap so we can see what's going on. That there and that there. There we go. I like that. Now, this is where I would suggest, we've just created a instance, a 2D instance grid. If I go ahead and grab all of these nodes from here to here and group them, Control G. So I need a instance on my input. So I'll do this, and I'll say my input is called instance, not instance. Instance. There we go. Gotta learn how to spell. It's a good skill to have. Now I could pull out my x direction, x amount. I could pull out my y amount. I could pull out my, well, if I wanted to, I could just say the x and y gap is going to be just the same. Show my PC Studio. I don't. If I move my camera right now, I might not be able to get it to stay back where it's at. It's kind of precariously placed. Um, but maybe next time I can show off my studio. Um, what I will tell you is I'm actually in the furnace room of my house. So like to my right is a couple of big furnace units that I actually shut off the furnaces while I'm recording so that they're not blowing in my ear. So it's really not that fancy. It's a desk in the corner of a basement room. Uh, I just happen to have my guitars hanging up behind me and a little corner desk. So nothing too special. Sorry. Um, so here now, this value on the other system resources compared to doing it without using duplicate elements node. Like we have duplicate of object versus instance of object. My image is reversed. Well, both. Um, I am left-handed, but I pretty much do everything right-handed except right. And I hold my fork with my left hand, and but I play guitar right-handed. I throw baseball right-handed. Um, I don't know. I shake hands right-handed. I wear my watch on the wrong hand. I'm just weird. Um, as far as the efficiency goes, I think your efficiency is going to be, well, in this case, um, I have two eyes, but I am right eye dominant. So go figure. I know that because I just went to the eye doctor the other day. Um, so as far as efficiency goes, this is going to be like this because I'm duplicating instances and I'm just creating instances. This is going to be more like Alt D um, memory usage rather than just straight up duplicating the objects. Now, if I wanted to wreak a little havoc on my system, I could obviously drop um, a realize instances node at the end, and that's going to turn it into one giant mesh. But I will try to avoid that. If or try to avoid that. Um, more of a 2D array than grid. Sure, it's it's yes. 2 points to Gryffindor. Um, just kidding. Uh, so anyhow, so we have our 2D array. Thank you very much. With our instances on it. And so if I tab out of this, well, let's call this spacing. If I tab out, now I can change my amounts quite a bit. But like as you can see, like I dialed that up to 13,000, like, and it doesn't even hiccup. Um, so super smooth. So now that I have that, I'm gonna replace my original cube. Or I'm sorry, um, my original grid with cube instanced on it. Grab all these, delete them. I'm gonna plug that into here, and then plug this into here. All right. So now I'm starting. I've got 143,000 instances at this point. I'm starting to feel a little bit of an effect in my performance. I've got the AMD. Which one was it? I forget. It was real mid range. It wasn't. Um, oh, I can't even think. I bought it about two. Well, I bought it like 4 months before COVID hit. So, and it was real mid range then. It wasn't anything super special. But I can't think of the number on it. X it was an X series. It doesn't have a GPU on board. It is a I think it's an 8. Give me a second. All right. Okay, it is an AMD Ryzen 7 3700 8 core processor. Um, It's got 8 cores and 16 logical processors. Um, I've got 32 gig of RAM, and I am running an NVIDIA RTX 2070 Super for my graphics card. Um, okay, so back to this. I'm going to dial this down just a little because there we go. All right, so now if I go ahead and bump this up, pretty cool. I'm gonna try to turn on my um, I'm gonna try to turn on rendered view. Let me know right away though if my audio gets choppy. I've noticed occasionally when I switch to um, rendered view uh, that it can act up on me. Let me make sure that I'm not using my system. Let's not use the processor. Sure. Let's see if this works. So, so that's pretty nifty. Um, what is this? The geometry node Boolean works as exact Boolean as fast Boolean. The Boolean in the geometry node is very slow. There needs to be a fast version. Yeah, I think. Okay, cool. Thanks for letting me know. Um, if it kicks in, it gives me problems. Just please hit me up in the chat. Um, yeah, I know there's been talk about adding in the fast mode for Boolean. Uh, I don't know. Um, Redoing the modifiers as nodes has not been really in my what I've been working on. Of course, I've been doing a lot of curve stuff and a few other odds and ends like this. Um, this was my big project really for 3.2 because it took this took about 2 months of on and off work to get. So it was multi-threaded. It didn't crash all the time, um, and that was as efficient as possible and really fit in with the whole design went. So, um, but as far as how I can't, I'm sorry you can't. Um, there you can do your own little trench run. Um, but as far as the modifiers go, I know there's plans for getting um, a bunch of the other modifiers done. Um, uh, for getting a bunch of the other modifiers done and put in. I just don't know what the timeline is on those. I know the person who was working on them had like they did it in a like a summer of Google Summer of Code and got quite a ways on quite a few of them, but that was before Fields, and then they had to take kind of a hiatus for a while. And then by the time they got back, Fields had been implemented, and a bunch of their work had to be redone. So that delayed a lot of the uh, development for some of the modifier, like the modifier stack modifiers being redone as nodes. I know there's actually the thought of, in the future, as we re-implement some of these things more efficiently in geometry nodes, because of, mainly because of fields. um yeah, I'm going to get to the planar node here just in just a minute. um that we'll actually be able to re-implement some of the built-in modifiers in geometry nodes and have them be more efficient than they were before. But then the idea is we would leave the modifier stack the way it is, and if you added, say, a subdivision surface modifier, um, then you could it would just add a geometry node modifier with pretty much just that single node in the middle of it. And it would be able to make use of the modifier stack, or the geometry node architecture, um, but be built like, but still just kind of look like a subdivision surface modifier, and would act the same way as a subdivision surface modifier. But if you really wanted to, you could crack it open, add in other nodes if you really wanted to, and tweak it. And so I think that's kind of like the hope that we'll eventually be able to do that. That's going to take a while to get there. So that, as a, like, quick and dirty, you could just add some of these things in like you would a modifier, but then in the long run, that's really creating something that you can go in and tweak to your heart's content. All right. Um, all right. Are there any other questions or on what I've shown so far with duplicate? Um, if they're not, I will. I'll throw up an example here of the new planar node, so you can see what that does, and I'll explain a little bit. Uh, Sorry, I'm just reading your comment here. So Blender gets slow. You have to manually hide all the modifiers. Yeah. But yeah, totally. Try, just start messing with this node. Do some cool stuff with it. Show me on Twitter. Tag me at Johnny Gizmo. I would absolutely love to see what you're doing with, well, geometry nodes in general. I've just seen some amazing things lately that people have been doing, and it's funny because here I've coded all these nodes, and then I go and see people just using them far beyond what I thought you'd be able to do with them, and just doing some really crazy, amazing stuff. So I want to see what you're doing. Certainly tag me on Twitter. I love it, love it, love it, love it. Um, uh, oh, my link is broken. Well, just search me at Johnny Gizmo on Twitter. I will go and try to fix my link. I don't know why that's broken. I don't like that. I will have to go back and fix that. Um, so, all right, let's save this one. We'll call it Stream 2. All right, let's check out the new planar node. Now, the idea with this node is that if I've got let's say I've got a face like this. If this were, I don't know, a piece of wood, I could, it would lay flat on the table. Okay. Because technically, all of these points are along the, on the Z, or well, not they're not at zero, but they're. I'm just gonna move them up. Okay. So all the points are at Z 0. So all the points are on the same plane. Now, if I take this and I rotate it like this, all these points are still on the same plane. Um, uh, David, that's great. I'm glad you're able to do that. That's not going to be um, you're not going to get the multi-threaded uh, copying of attributes the same way. Um, I would be curious to see your performance of the same setup between the two different setups once you get up to 100,000 instances or more. But cool. I'm glad. That's the cool thing with geometry nodes. There's a ton of different ways to do everything, and there's no, if you're getting the results you want, there's no wrong way to do it. There might be more efficient ways to do it. There might be less efficient ways to do it, but you can really do things a bunch of different ways, and whichever way makes the most sense to you. So back to this planar node, all of these points are still on the same plane. This is still a flat thing. But if I take this back here and I take one of these points and I move it up, even though this is a face, it's no longer a flat face. Um, it's got like a little bit of a bow to it, but there's no geometry to actually, yeah, there's no actual geometry to allow this to be bent. It's just going to be, but it is. So it's almost kind of an impossible shape at this point. Now, what the so if I take this and let's grab these 2 points and extrude them out. So now I have this face is planar and this face is not. I'll add a geometry nodes here, and I'm going to add a mesh face is planar node. I will control shift click on my geometry and on my faces planar node. And what we're seeing here, and I will go here and turn on indices. So face 0, get rid of the 3D cursor. We don't need that right now. Okay, so face 0 here is not planar because it's bent like that. All of the points don't lie on the same geometrical plane. And then face number 1 is, because they do. One of the things we could do, get rid of this. If I were to add if I were to render this, let's go to cycles. you see that we are getting, even though we don't know it, just by looking at, if I'm in, say, flat shaded mode here, other than that this point is higher, I really don't have a good indication that this plane is going to render weird. But if I go into rendered mode, you'll notice that I've got this triangulation here happening. Um, Sorry, hold on. You want to send me $100? You go right ahead. There's that little button there in the chat. You are more than welcome to send anything you want, but whatever. Okay, so there's no real indication that we're going to get this triangulation in our model, um, but yeah, sorry, I'm a little distracted at the moment. Okay, so if I were to add a where is it, triangulate node to this model, you'll see that I now have 4 faces. And to help see what's going on here, I'm going to turn on wireframe. Okay, so I'll pull out the triangulate node. So right there, okay, back in flat shaded mode. So we've got these 2 faces. We really can't tell that this one's going to triangulate when I render it. But now if I add my triangulate node, I see, okay, I'm going to get this triangulation, or I could, I could change this to whatever mode that I, felt like I wanted. But I've triangulated this other face unnecessarily. And so maybe I don't want that. So what I can do is I can say to only triangulate the faces that are not planar. So here, if I drop my planar node into my triangulate, right now it's triangulating all of the planar nodes. So I actually want the inverse of that. So I will add a Boolean math node and set it to not. So now, if I have faces that are not planar, they're going to get triangulated. If they are planar, they won't get triangulated. So here's one way we could tie this in with duplicate. If I go ahead and add in a duplicate elements node here, and I put this in face mode, and then I set my position, and we'll just do, just because it's easy, we will do the normal of the faces as my offset. And, oh, my faces are backwards. There we go. And then I'm going to scale that. Vector math. Scale by the duplicate index. And then we want to, we could use the new scale elements node, which is under mesh, scale elements. It's under mesh because it only scales mesh elements. So I want to scale faces, and I want to scale them by the duplicate index, but I want the inverse of that, so I'm going to go math divide 1 over. Okay. Um, and we'll just do this real quick too. There we go. All right. So now each face is being duplicated out, and it is going along its normal. If I triangulate, you see it's cutting both of them, but I only want to cut the one that is non-planar. So now this one is giving me the triangles pointed in the two directions that the face triangulates into, and the flat one stays flat. The other benefit of this node also is that, give me a second, if I, say I create an n-gon. This also works with uh, get rid of this real quick. So if you have an n-gon that is not planar, it will also respond to um, the face's planar node as well. And this threshold is how far a point needs to move away from the plane before it's considered off the plane. So you can set that really small, and then it is more and more perfect. But since it's comparing floating point values, having it be exactly 0 can cause trouble. So yeah. Apparently we ruined the scale elements node. I did not have anything to do with the scale elements node. I was not aware that it was ruined, but interesting. I'm sorry that you're unhappy with the scale elements node. It was new. Sorry you're unhappy. Um, Not much I can do about that one. All right. So So yeah, those are the two nodes that I really wanted to cover tonight. Um, let's see. We are play GTA 5. I don't have GTA 5. I'm sorry. And um, this would be more of a comedy podcast if you were watching me play any kind of game. Um, Maybe I could play some Tetris for you. That might be as entertaining as it gets. But yeah, no, I'm not much of a. I mean, I enjoy a good video game from time to time, but I am not good at them to say the least. So that would not be an enjoyable stream. Um, let's see here. Nodes are the best game. Uh, you're right. You're right. They are. I'm surprised nobody's programmed Doom in geometry nodes yet. My drink is mint tea, so I highly recommend some good mint tea. And my mug that my kids got me for last Father's Day. It's backwards, but it says Dad Joke Pro. So yeah. Uh, so any other questions? We're kind of at a hour and a half here, whatever we're at. So probably need to widen down pretty soon, but I could probably take a couple more questions uh, before I call it an evening. You've been great. I've been um, enjoying your comments. Uh, so I'll open up. Here's the node tree. Make my mug. Um, Here's the node tree from my post. And here I just did the instance on points with the grid and the cube, duplicated the elements using a texture, um, set the positions of the cubes, captured the duplicate index, and pass that out to my shader. And then in my shader, I just set um, the cubes based on the z index or the duplicate index. Um, uh, so yeah, this was fun. This was kind of a quick and easy. Not too many nodes, and really, if you take the texture stuff out, um, there's not much to this thing. Um, yeah, you can make things when you're just kind of tweaking values. You can there we go. You can make things come and go pretty quick. Yeah, I did see Sanctus's video. I was again super psyched that somebody just jumped in and started doing something really cool with it. And he did mention in his Twitter post that that uh, he noticed a performance increase in using the duplicate node over other methods where he got the same result using other methods, but he said the scrolling on the duplicate The duplicate node version was much faster and removed a whole bunch of extra nodes and really um, uh, consolidated a lot of stuff down. So very pleased to see that. Like I said, I love seeing when people take stuff that I've worked on and just take it far beyond any of my meager examples, for sure. Can we pass any custom attribute from geometry nodes to shader nodes? Sure. Just well, I don't know that I had to do this realize instances here. I think I just was in a hurry to get this project out, so I didn't want to mess with it. But so I just captured the duplicate index here, captured it as a float, and pulled it over to the group output. Then in my modifier, you give that a name. So here on the group output, it's called duplicate index. So here it is, duplicate index. Give it a name here. And then over in my shader, I've got an attribute, um, and I use the name that I put into my modifier here. I put that here, and now I'm able to access that attribute from my geometry nodes. So yeah, you can do that, and it gives you quite a bit of power. Um, can I up the count and show my specs? Sure, why not? Why not? This one I didn't do my dynamic 2D array there, so let's see here. So if I do let's see, so the 40 and 4.2. So if I do 100 and 12. Um, oh, and I've also got cycles running here. I'm gonna drop this into. And I'll leave it on there. It's fine. All right, yeah. Trying to do this in. See, I think this is where it would have been much better for me to have the 2D array. I bet this is. I've just. Rutro, Rutro, Raggy. I think we're in trouble. um. Hey, that's pretty good to get through a hour and a half stream and only screw myself up that bad once when I tried to 100 by 100 grid. Give me 2 seconds here. I'll get this back up. It could have been the grid, and I'm really curious now if I used the 2D array of duplicates instead of the grid, if I would have had that issue. I kind of think I might not have, but I'm not going to rebuild that right now to show that. Um, but But yeah, just be careful when you're duplicating stuff that you don't, you know, exponentially put in something that's going to just grind you to a halt because you just created, a million instances of something when you really only meant to create 100,000 of them. You know, an order of magnitude off can mess things up. Um, Vertically with the node to see its performance of the node you just made a huge grid. Well, yes. Like this. I'm gonna open up a spreadsheet here so we can see what we've created. Oh, and I'm realizing instances too. So this is all just one mesh. These aren't instances. That's another problem. That might be why. Uh, yeah, there's the timings. Um, if I get rid of this realize instances, or at least mute that, now I've got instances rather than one gigantic mesh. Because this was sitting at, right now, this is sitting at 660,000 vertices um, in one mesh, as opposed to 82,000 instances. Um, yeah, I do love Blender's auto saving. Has saved my bacon more than once, for sure. There'd be a lot of work lost if that wasn't the case. So specs for reference. Like I said, it's a 8 core, 32 gig of RAM. All right. Let's see what we have here. All right. So if I take this up, we'll go back up to where we were before at like. Okay, so here we are. Um, all right. Change the graphological cores. There, how's that? Does that look good? Okay, so here I am sitting at just under 600,000 vertices. Um, And then let's see, Blender's using a gig of RAM at this point. Now I'm curious if I go ahead and undo realize instances, mute that. That just cut 200 meg of RAM usage um, by getting rid of uh, those. And if I bring these down, I mean, yeah, it's chunking along for sure, but and again, I'm in rendered mode this whole time. So yeah, um, there's you know, quite a bit, you can do. I hope that at least answers a little bit of your questions. Of course, I'm also, recording and streaming here at the same time, so that's doing a number as well. But yeah, you can definitely see that that's getting spread out across the cores. Um, all right, so um, yeah, I think that's unless there's any last minute questions, I think I'm about done for the evening. Um, David, I'm not sure exactly what you want when you say frame it. Are you just wanting me to do this? This? Um, thanks for coming out. I appreciate you guys all hanging in there through the stream and contributing in the chat. Uh, Keep an eye out. I know I don't do live streams very often, but uh, you're welcome. Um, but I certainly appreciate the support and all the nice comments that you all leave on my videos and on my Twitter. And um, can you not see? Um, so just keep it coming. Keep hitting me up on Twitter. And just feel free to ask me questions there. I can't always just I can't always get right back to you immediately, but I will do my best to answer questions if I understand your question um, on Twitter. Um, so, like I said, please show me anything you happen to build, either with geometry nodes or really anything. I just really like checking out what other people are doing and all that. So, with that said, I will bid you all a fair good night, as it is currently 11 o'clock in the southern Illinois area. I hope you had fun, and I hope this inspires you to make something awesome. And until next time, I'll catch you later.